So the binomial distribution is used to find probabilities, and it is used if the following conditions are being followed. The conditions are that firstly there should be discrete data, discrete outcomes. Then the events should be independent. There should be two defined groups of outcomes. That is, two groups of outcomes, success and failure. There can't be more than two outcomes. Success is represented by P and failure is represented by Q. Next, the number of trials should be fixed. Take an example to explain this better. So, for example, I have a three-sided fair dice. Now that the faces of the dice are numbered 1, 2 and 3. Now over here the success is that we get the number 2. Getting the number 2 is success. So the probability of success will be getting 2. The probability to get 2 is 1 over 3 because it's a fair dice. And the probability of failure would be that you get a 1 or a 3. So that would be 2 over 3. Now for example, we have 4 dice and we have to find the probability of getting 2 twice, right? So we are throwing this dice, like we have 4 of these dice and we're throwing them one by one, and we have to get 2 twice. So the probability of getting 2 on the first dice would be 1 over 3. If we get 2 again on the second dice, that's 1 over 3. Now on the next 2 dice we can't get 2 because you have to get 2 only twice. So then it would be 2 upon 3 for the next dice, and for the fourth dice again 2 upon 3, right? Now we can arrange this in different possibilities. Maybe you get 1 or 3 on the first dice, or you get 1 or 3 in the second dice. So we'll multiply this by 4 factorial because there are 4 of these, and divide it by 2 factorial times 2 factorial because this is repeated twice, so that's why 2 factorial. This is repeated twice, so 2 factorial. So this will give us the probability of getting 2 twice only. Now in what other way could I write this expression? 4 factorial upon 2 factorial and 2 factorial can be written as 4c2. Basically the formula for NCR is n factorial upon n minus r factorial times r factorial. So if you match these, n is 4 and r is 2, so 4c2. So I'm writing 4c2 in place of this. Now I can write this as, in fact first I'll write the failure. I can write the failure as 2 over 3 whole square, right? And then I can write the successes as 1 over 3 whole square. So if I would want to form a general formula, that would be n, that is the total number of trials, x, the number of successes we have to get. If you notice, this is 4 minus 2, so you can write this as n minus x. Sorry, we'll have q over here. This was the probability of failure, so we'll have q over here, and then times, this is the probability of success, so p, and this would be power x. So this is similar to the binomial expansion formula that we did, NCR into a to the power n minus r times b to the power r. So over here we have NCx times probability of failure power n minus x times probability of success power x. This is the formula for the binomial distribution. So here we have the formula again. Now how do we write this? So we write x follows binomial, x is the data, and the parameters over here are n and p. So n is the number of trials and p is the probability of success. Now what other formulas we have over here? We have the formula for expected value, that is mean. This is equal to the total trials into the probability of successes, that is NP. Then there is variance. The formula for variance over here is total trials into probabilities of success into probability of failure, and standard deviation is the root of the variance, so it will be root NPQ. These are the formulas that we'll be using. For example, we have any given scenario where we're having 10 trials and we have to find the probability of less than 3 successes. So this means that we either have 0 successes, 1 success, or 2 successes. So what we'll do is we'll write this as p x is less than or equals to 2, right? So this will be equal to probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. So then you'll apply this formula for each of them and you'll add them together. If for example we have 10 trials, and we have to find the probability of more than 3 successes. First it was less, now it's more than 3 successes. So basically there can be 4 successes, 5, 6, 7, 8, 9, or all successes. Now one thing you could do is you could use this formula again. You'll have px equals 4 plus px equals 5 plus px equals 6, and then you add them all up. Or the shortcut, basically first I'll write it in notations. So we have to find px is greater than or equals to 4, right? What I can do over here is to simplify my working. I can write this as 1 minus because firstly we know that the total probability is 1. It cannot be greater than 1. So the total probability is 1. From that, if I subtract the probability of x being less than 4, that is 0, 1, 2, or 3, then I'll get this probability. So I'll use the shortcut. Over here I'll apply this wallop thing, and that's how I'll get it by a shortcut. The first question. In this question we have the mean that is given as 1.6 of 20 packs of batteries. So firstly, the mean is also called the expected value. For the expected value we had the formula NP. Expected value is given as 1.6, n is 20 times p. So I can get p, p will be 0.08. right? Now they're saying that use a binomial distribution. They've said it over here, so you don't have to find out. To calculate the probability that a randomly chosen pack of 20 will have more than 2 defective batteries. So they're saying that there are total 20. Basically there is x follows binomial, total trials are 20, and success key probability is 0.08. Now what they're saying is that we have to find the probability that more than 2 defective batteries. So x is greater than 2, right? Now I can write this as 1 minus probability of x is less than or equals to 2. So now what I'll do is I have 1 minus probability of x is equals to 0 minus probability of x is equals to 1 minus probability of x equals 2. So probability of x equals 0 will be total are 20 C0 times. Okay, so this was the success. Failure, one more thing that I'll mention over here is that because the total probabilities are 1, so probability of success plus probability of failure equals to 1. So probability of failure equals 1 minus p. So the probability of failure would be 1 minus 0.08, that is 0.92. So now coming to the formula, 20C0, then the probability of failure is 0.92 power 20 times 0.08 power 0 minus 20C1 dot 0.92 power 19 dot 0.08 power 1 minus 20C2 times 0.92 power 18 times 0.08 power 2. So this is coming equal to 0.2121. You can write it as 0.212223 SF. So that is the probability of there being more than 2 defective batteries. Next question. Krista takes her dog for a walk every day. The probability that they go to the park on any day is 0.6. If they go to the park, there is a probability of 0.35 that a dog will bark. If they do not go to the park, there is a probability of 0.75 that a dog will bark. Okay. So we don't need a tree diagram over here, but we'll just draw it for it might help us in the parts. So the probability that they go to the park is 0.6, and the probability that they don't go to the park will be 0.4, obviously. Now if they go to the park, then the probability for the dog to bark is 0.35, and then obviously for the dog to not bark is 0.65. And if they do not go to the park, then the probability of the dog to bark is 0.75 and not to bark is 0.25. This is the T diagram, not needed, but I just do it. Now the first part, find the probability that they go to the park on more than 5 of the next 7 days. So now what they've done is they gave us 7 days, that is a fixed number of trials. And they're talking about going to the park, so the probability of success will be 0.6 and the probability of failure will be 0.4. Now we have to find the probability of x greater than 5, right? That is equal to probability of x equals 6 plus probability of x equals 7. So for 6, 7c6 times probability of failure was 0.4 power 1, 7 minus 6 is 1, times 0.6 power 6 plus 7c7 times 0.4 power 0, 7 minus 7, and then 0.6 power 7. So solving this, 0.159. This is the answer to the first part. For the second part, find the probability that the dog barks on any particular day. This is just a probability question. So the probability that a dog barks, so over here we'll use the tree diagram. So for the dog to bark, it could be this possibility, if it's visible, or it could be this possibility, right? So it is 0.6 times 0.35 or 0.4 times 0.75. This is equal to 0.51. Now the third part, find the variance of the number of times they go to the park in 30 days. Okay, so now what they've done is they've made the total number of trials, the total number of days as 30. Our probability of success was 0.6 and for failure was 0.4, obviously. And they're saying find the variance. We did the formula for variance in the beginning. So variance of x equals NPQ, the product of the three. So 30 times 0.6 times 0.4 this is equal to 7.2. Next question, biscuits are sold in packets of 18. There is a constant probability that any biscuit is broken independently of other biscuits. So these are independent events. The mean number of broken biscuits in a packet has been found to be 2.7. So mean or expected value is 2.7. The total number of trials or the total possibilities are 18. Then they're saying that find the probability that a packet contains between 2 and 4 inclusive broken biscuits. So we have to find probability of x being greater than or equals to 2 but less than or equals to 4. First I'll use these to find the probability of success. So expected value equals NP, 2.7 equals 1.8p, p equals sorry 18p. This is 18. So probability is coming 0.15. Now the probability of failure will be 0.1 minus 0.15, so 0.85 if I'm not wrong. Now we have to find the probability of x being greater than or equals to 2 but less than or equals to 4. That is equal to the probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4. So for x equals 2, the probability will be, there are a total of 18 events, right? So 18 C2 times 0.85 power 16, 18 minus 2 is 16, times 0.15 power 2 plus then 18 C3 times 0.85 power 15 times 0.15 power 3 plus 18 C4 times 0.85 power 14 times 0.15 power 4. This is equal to 0.655. Question, find the first part, find the probability of getting at least 1 3 when 9 fair dice are thrown. So A1, n equals 9 and we have to get 1 3, so P will be in a dice, the probability of 3 coming would be 1 over 6 and then the probability of failure would be 5 over 6. Now we have to find the probability of getting greater than or equals to 1. You have to get 3 at least once, 1 or more than once. So this will be equal to 1 minus the probability of x equals 0, that is equal to 1 minus 9c0 times 5 over 6 power 9 times 1 over 6 power 0. So this is equal to 0.806. Second part, when n fair dice are thrown, the probability of getting at least 1 3 is greater than 0.9. Find the smallest possible value of n. Now in that part we had n equals 9, now we don't know n. Now again we have to find the same probability, that there is at least 1 3. So I'll use the same formula, equals 1 minus probability of no 3. Now this probability, it's given the question is 0.9, is greater than 0.9. So 0.9 is less than this probability, that is 1 minus, now for this we'll have nc0 times 5 over 6 power n times 1 over 6 power 0. So if I shift this to that side, we'll have 5 by 6 power n is less than 1 minus 0.9, that is 0.1. I can apply log over here. So if I apply log to both sides, I'll have n log n ln 5 by 6 is less than ln 0.1. Now ln 5 over 6 is negative 0.182. So negative 0.182n is less than ln of 0.1 is negative 2.3. So both negative signs on both sides, if we cancel out the signs, this inequality will switch. So n is coming greater than 12.7. So we have to find the smallest possible value of n. So that will be 13. This question isn't really from binomial distribution, but it's from probability. I'll just do it still. So it's saying that a bag contains 5 green balls and 3 yellow balls. Ronnie and Julie play a game in which they take turns to draw a ball from the bag at random without replacement. The winner of the game is the first person to draw a yellow ball. Julie draws the first ball. Find the probability that Ronnie wins the game. Okay, so Ronnie has to win the game. That means that Ronnie is the first person to draw a yellow ball. Julie cannot draw a yellow ball. So the first possibility is that Julie draws a red ball, right? And then I'll represent red ball with this bar wala sign. So Julie draws a red ball, sorry, green ball. This is a green ball. And then Ronnie draws a yellow ball. So I didn't show the bar. So Ronnie wins in this case. The second possibility would be that Julie draws a green ball, Ronnie draws a green ball, then Julie draws a green ball, and then Ronnie draws a yellow ball and he wins. The third possibility is that Julie draws a green ball, Ronnie draws a green ball, Julie draws a green ball, Ronnie draws a green ball, Julie draws a green ball, and then Ronnie draws a yellow ball and Ronnie wins. These are the 3 cases when Ronnie can win. There can't be more cases because there are a total of 3 yellow balls. Now we have to find the probability of all of these. So for the first one, the probability would be Julie has to draw a green ball. So out of the 8 balls, she can draw 5. And then Ronnie has to draw 3 out of the remaining 7. This is equal to 15 over 56. In this one, Julie has to draw a green ball out of the 8. Then Ronnie has to draw a green ball. Then Julie has to draw another green ball. Sorry, this will be 4 upon 7. Then 3 upon 6. And then Ronnie has to draw a yellow ball. So 3 upon the remaining 5. This is coming equals to 3 over 28. For the third case, Julie draws a green ball, Ronnie draws a green ball, Julie draws a green ball, Ronnie draws a green ball, Julie draws a green ball, and then Ronnie draws, sorry, this is 5, this is 4, and then Ronnie draws a yellow ball. So for this, the probability would be 1 over 56. So we'll add them all up. This is coming equal to 11 upon 28. So in this question, a biased die was thrown 20 times and the number of 5s was noted. This experiment was repeated many times and the average number of 5s was found to be 4.8. Means the mean or the expected value of 5s was 4.8. And total trials were 20. finds probability that in the next 20 throws the number 5s will be less than 3. So either 0, 1 or 2, 3, 2 5s. Now this is the expected value. The formula for expected value is NP. So we'll get P equals 0.24. So Q will be 1 minus 0.24, that is 0.76. Now probability of x less than 3 means probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. So for x equals 0, the probability will be 20 C0 dot 0.76 power 20 dot 0.24 power 0 plus 20 C1 dot 0.76 power 20 minus 1, that is 19 times 0.24 power 1 plus 20 C2 times 0.76 power 18 times 0.24 power 2. So this is coming equal to 0.109. Next question, the probability that Sue completes a Sudoku puzzle correctly is 0.75. Sue attempts n Sudoku puzzles. So firstly, probability of completing it of success is 0.75 and n equals n. Q will be 1 minus 0.75, that is 0.25. Then they're saying find the least value of n for which the probability that she completes all n puzzles correctly is less than 0.6. So probability that x equals n is 0.06. Okay. So now 0.06 equals n cn times 0.75 power 0, because n minus n is 0, times this was 0.25 failures, and then 0.75 for the successes, power n. NCN is 1, 0.25 power 0 is 1, so 0.06 equals 0.75 power n. Actually, one mistake I've done over here is that they had said that find the least value of n for which the probability that she completes all n puzzles correctly is less than 0.6. So this is less than 0.6. It's less than 0.6. Now I'll use log over here. So ln 0.06 is less than n ln 0.75. So ln 0.06 is negative 2.81 is greater than ln 0.75, which is negative 0.29n. So inequality will be reversed and n will come greater than, n is greater than 9.77, so n will be equal to 10. That was the first part. Now for the second part, they're saying Sue attempts 14 Sudoku puzzles every month. The number that she completes successfully is denoted by x. Find the value of x that has the highest probability. You may assume this value is one of the two closest values to the mean of x. Right, so now she is attempting 14 Sudoku puzzles. And again, p equals 0.75 and q equals 0.25. So they're saying that we have to find the value of x that has the highest probability, and they're saying that this value is one of the two values close to the mean. So I'll first find the mean. Mean is the expected value. The formula for that is n into p, so 14 times 0.75. That is coming equals to 10.5. So now they're saying that the highest probability value is one of the two values close to the mean of x. So close to the mean of x, the two values are 10 or 11. So I'll find px equals 10 and px equals 11. Whichever has the greater probability, that will be the value with the highest probability, right? Or you can even call that the mode, because the mode is the number with the highest probability. So px equals 10. For that, 14c10 times 0.25 power 14 minus 10 is just 4 times 0.75 power 10. And for px equals 11, 14c11 times 0.25 power 3 times 0.75 power 11. This is coming equals to 0.22 and this is coming equal to 0.24. So that means that the mode will be 11, as it is the number with the highest probability. In the last part, they're saying find the probability that in exactly 3 of the next 5 months, Sue completes more than 11 Sudoku puzzles correctly. First, I'll find the probability of completing more than 11 Sudoku puzzles correctly. So Sue attempts 14 puzzles per month, so n equals 14. P equals 0.75 and Q equals 0.25. Now more than 11 Sudoku puzzles correctly, so Px greater than 11 equals to Px equals 12 plus Px equals 13 plus Px equals 14. So I'll do this quickly. 14c12 times 0.25 power 2 times 0.75 power 12. So this is coming equal to 0.281. Now this is the probability of completing more than 11 Sudoku puzzles in 1 month. Now we have to find the probability that in exactly 3 of the next 5 months she does this. So for this part, this will be, now we have another binomial distribution. First we had one for a month, now we have another one for the next 5 months. In that, n will be 5. In that, P, the probability for success will be 0.281 because success is completing more than 11 Sudoku puzzles. And for failure, it will be 1 minus 0.281, which is 0.719. Right? Now over here, she has to get exactly 3 of the 5. So P should be x equals 3. So 5c3 times 0.719 power 5 minus 3, which is 2, times 0.281 power 3. This is coming equal to 0.115. So I'll repeat this part again, it was a little tricky. So firstly, we had to find the probability that in exactly 3 of the next 5 months, Sue completes more than 11 Sudoku puzzles correctly. So first I found the probability that she completes 11 Sudoku puzzles correctly. For that I used n equals 14, p equals 0.75 and q equals 0.25. And I got that probability as 0.281. Now what they're saying were that in 3 of the next 5 months this should happen. So in that case, n will be 5. The successful probability is the probability of getting more than 11 puzzles correct, and that we found as 0.281. So the probability of failure will be 1 minus 0.281. out of 5 we have to get 3 months in which exactly 3 months in which this happens. So 5c 3 times and so on. So in this question, a company set up a display consisting of 20 fireworks. For each firework, the probability that it fails to work is 0.05, and the probability that it does not fail to work is 1 minus 0.05, that is 0.95. Now they're saying find the probability that more than one firework fails to work. So probability of x is greater than 1. This is equal to 1 minus the probability of x is less than or equal to 1, that is x equals 0, or probability of x equals 1. So this is going to be equals to 1 minus 20c0 times 0.95 power 20 times 0.05 power 0 minus 20c1 times 0.95 power 19 times 0.05 power 1. This is equal to 0.264. That is the first part. The second part, the 20 fireworks cost the company $24. 450 people pay the company $10 each to watch the display. If more than one firework fails to work, they get their money back. Calculate the expected profit for the company. So first I'll find the expected income. So there are 450 people, each person paying $10, so they should get 4,500 if nothing goes wrong. And their expected expense will be 24 for each. So 24 times 20 fireworks, that is 480. Right? Now I'll find the expected refund. So they're getting 4,500, right? To find the expected value of giving the refund will be in the case when more than one firework fails to work. And for more than one firework to fail to work, we found the probability in the first part, that was 0.264. So to find the expected value of the refund, we'll multiply this by 0.264. This gives the expected refund. 1188. We are using the formula for expected value, that is n into p. The favorable success over here was 0.264 and the total possibility was 4,500. So 1188 comes as the answer. So now the expected profit will be the expected income minus the expected expense minus the expected refund. That is 2832, or approximately equals to 2830.